Welcome to Learn with Roblox. In today's video, we're going to cover dividing and multiplying complex numbers. So let's get right into it. In this first problem, we need to multiply 6i plus 7 with 2i plus 4 and see what that turns into. So to do this, you just need to FOIL the expression or multiply in whatever order you want to. I'll show you how I do it. So to do this, I'm first going to do 6i times 2i. If I do that, that gets me 12i squared because you multiply the numbers and you multiply the i's. Next, I'm going to do 6i times 4. 6 times 4 is just 24, so there's 24 i's in here. Next, I'm going to do 7 times 2i. 7 times 2 is just 14, and then we have an I at the end. And then finally, I need to do 7 times 4, which is 28. So this is what the expression turns into, and I just need to clean this up a little bit. So first, when you have 12i squared, I squared is just equal to negative 1. So 12i squared is equal to 12 times negative 1. And 12 times negative 1 is just negative 12. So that 12i squared just becomes minus 12. And then if you have 24i plus 14i, we can combine those terms because they both have an I on them. So 24 plus 14 is equal to 38. And then there's an I afterwards. And then we have the plus 28. And then finally, we can combine the minus 12 and the plus 28. Minus 12 plus 28 is positive 16. And then just bring down the plus 38i from earlier. And just like that, we're done. In this problem, we're multiplying 1 minus I with minus 2 plus 4i. So to multiply this, I'm first going to do 1 times minus 2. 1 times minus 2 is just negative 2. And then I'm going to do 1 times 4i. That's just 4i again. And now I need to do minus I times minus 2. Those negatives cancel and we're left with minus or positive 2i. And finally we need to do minus I times 4i. Minus 1 times 4 is negative 4. And then I times I is just I squared. So this is our answer. Let's simplify it a little bit. So first, I have minus 2 here, and then 4i plus 2i is just 6 i's in total. And finally, minus 4i squared, well, I squared is just equal to negative 1. So minus 4i squared is minus 4 times negative 1. And minus 4 times minus 1 is positive 4. So this whole thing becomes plus 4. And then now we can simplify this even more. Minus 2 plus 4 is just equal to positive 2. And the 6i, we can't simplify that anymore because there's no more i's to add it with. So it's just 6i. And then that's our answer. In this problem, we have minus 3 plus 4i times 7i minus 10. To multiply this, I'm first going to multiply minus 3 and 7i. Minus 3 times 7i is negative 21i. Next, let's do minus 3 times minus 10. Minus 3 times minus 10, those negatives cancel and we're left with positive 30. Next, let's do 4i times 7i. 4 times 7 is 28, and I times I is just I squared. And then finally, we have 4i times minus 10. 4 times minus 10 is negative 40, and then just put an I at the end. Now let's simplify this expression that I've written in blue here. So first, I'm going to add minus 21i and minus 41, or minus 40i. Minus 21 minus 40 is equal to negative 61. And then just add an I at the end. And then I'm going to add 30. And then for 28i squared, well, remember, I squared just equals negative 1. So therefore, 28i squared is equal to 28 times negative 1. But 28 times negative 1 is just negative 28. Oops. And then finally, I'll have minus 61i plus 30 minus 28 is just 2. So minus 61i plus 2 is our answer. In this problem, we have 20 divided by 1 minus 2i. So I need to simplify this because there are i's in the denominator, and in general, we don't want to have imaginary numbers in the denominator of a fraction. So how can I do that? How can I get rid of the 2i in that denominator? What you need to do is you need to find the complex conjugate of the complex number in the denominator. What is a complex conjugate? Well, if you have a number in the form of a plus bi, such as 3 plus 2i, its complex conjugate is just you make it a minus bi. That means you flip the term on the imaginary part. So 3 plus 2i would have a complex conjugate of 3 minus 2i. Okay, but in our example up here, we have 1 minus 2i. So what if we have something in the form of a minus bi, like 1 minus 2i? The complex conjugate is, once again, you flip the sign on the imaginary part. So you get a plus bi. So the complex conjugate for 1 minus 2i is just 1 plus 2i. So we're going to need this complex conjugate. Now, what do you do with this complex conjugate? What you need to do is you need to take your fraction and multiply it by that complex conjugate on the numerator and the denominator. So I'm going to have times 1 plus 2i at the top, and then 1 plus 2i at the bottom. So now let me just rewrite this as one big fraction. I'll have 20 times 1 plus 2i, and I'll have 1 minus 2i times 1 plus 2i. So now we just need to multiply these out. Let's start with the numerator. 20 times 1 is just 20. 20 times 2i is just 40i. So the numerator just becomes 20 plus 40i. Now we need to multiply the terms in the denominator. So to do that, I'm going to do 1 times 1 is just 1. 1 times 2i is just 2i. Minus 2i times 1 is just minus 2i. And then minus 2i times plus 2i is minus 4i squared. And then to simplify this, notice that the 2i and the minus 2i cancel out. And all we're left with is just 1 minus 4i squared. Well, I squared is just negative 1. So this is just equal to minus 4 times minus 1. And minus 4 times minus 1 is just plus 4. So we have 1 plus 4, and notice that's just 5. In other words, this whole denominator here just simplifies as 5. Now, do you see how by using the complex conjugate, we were able to eliminate the complex number at the bottom and just be left with a real number? Now we just need to divide. So to divide this, we'll just have 20 plus 40i divided by 5. That's equal to 20 divided by 5. Plus 40i divided by 5. 20 divided by 5 is just 4. And then 40i divided by 5, well, 40 divided by 5 is just 8. So we're left with 8i. And that's it. That's how you divide complex numbers, or how you divide by complex numbers. In this problem, we have 1 plus 3i divided by 3 plus 2i. So I need to simplify this because we have an imaginary number in the bottom of the fraction and we don't want that. So how do we get rid of it? What you need to do is you need to find the complex conjugate of the denominator. So remember, the complex conjugate of a complex number is you take the imaginary part, that's positive 2i, and you just flip the sign on it. So the complex conjugate to 3 plus 2i is just 3 minus 2i. I'll just call it CC for the complex conjugate. But now what do you do with the complex conjugate? What you need to do is you need to multiply the numerator and the denominator by that complex conjugate. 3 minus 2i. 3 minus 2i. So now let me just write this as one big fraction. So I'll have 1 plus 3i times 3 minus 2i. And then on the bottom, we'll have 3 plus 2i times 3 minus 2i. So let's work on the numerator first. I have 1 plus 3i times 3 minus 2i. To simplify this, let's do 1 times 3 first. 1 times 3 is just 3. And let's do 1 times minus 2i. That's just minus 2i. And then 3i times 3 is just plus 9i. And then 3i times minus 2i is negative 6i squared. So first, minus 2i and plus 9i, that just becomes minus or plus 7i. So I have 3 plus 7i. And then next, 6i squared. Well, I squared is just negative 1. And then minus 6 times minus 1 is positive 6. And then I can do 3 plus 6, and that's just 9. So all of this just becomes 9. Let me write this. 9 plus 7i. So that's our numerator. Let's work on the denominator now. So first, I'm going to have 3 times 3. That's 9. And then 3 times minus 2i is minus 6i. And then I'll have 2i times 3 is plus 6i. And then 2i times minus 2i is minus 4i squared. So first off, this minus 6i and plus 6i cancel out to get 0i. So all I have is minus 9 minus 4i squared. I squared is just minus 1. And then minus 4 times minus 1 is plus 4. So I just have 9 plus 4. And 9 plus 4 is 13. So this whole denominator is just 13. So my final expression is 9 plus 7i divided by 13. And I can break this down into 9 divided by 13 plus 7i divided by 13. And just like that, we've managed to divide complex numbers. In this problem, we have 10i minus 5 is divided by minus 7 plus 3i. As always, we don't like having a complex number in the denominator, so we need to find a way to get rid of it. To do that, we need to find the complex conjugate of the denominator. The complex conjugate is what happens if you take the I part, that's plus 3i, and flip the sign on it. So the complex conjugate, which I'll abbreviate as CC, of minus 7 plus 3i is minus 7, don't change that number, and then change the sign on the I part. So plus 3i becomes minus 3i. And then what do you do with this complex conjugate number? What you need to do is you need to multiply the numerator and the denominator by that complex conjugate. So we'll have 10i minus 5 times minus 7 minus 3i. And on the bottom, you'll have minus 7 minus 3i as well. So when we're multiplying fractions, you just put them together like so. So I'll have minus 10i minus 5 times minus 7 minus 3i. And then on the bottom, I'll have minus 7 plus 3i minus 7 minus 3i. Now let's work on the numerator first to simplify this. So we just need to multiply two complex numbers. To do this, let's just do 10i times minus 7. That's minus 70i. Let's do minus or 10i times minus 3i. That's negative 30i squared. Next is minus 5 times minus 7. That's positive 35. And then finally we have minus 5 times minus 3i. That's plus 15i. So now let's simplify some terms. First off, I know that this minus 70i and plus 15i can be combined. Minus 70 plus 15 is just negative 55. So I have negative 55i. And then for that minus 30i squared, I squared is just negative 1. So in other words, all we have is minus 30 times negative 1. And minus 30 times minus 1 is positive 30. And then 30 plus 35 is just 65. So this numerator just simplifies to minus 55i plus 65. I'm just going to erase all this stuff and put it down here. So I have minus 55i plus 65. Now let's work on the denominator. Minus 7 times minus 7 is positive 49 because those negatives cancel. Minus 7 times minus 3i is positive 21i. And then 3i times 7 is negative 21i. And then 3i times minus 3i is negative 9i squared. So first off, this plus 21i and minus 21i cancel out. And we're left with 49 minus 9i squared. I squared is just equal to negative 1. Minus 9 times minus 1 is just plus 9. 49 plus 9 equals 58. So this big denominator here just turned out to be the number 58. So once again, notice how by using a complex conjugate, we were able to eliminate any i's in the denominator. And then now let's just divide this. So if you have minus 55i plus 65 divided by 58, this gets you minus 55i divided by 58 plus 65 over 58. And this is it. This is our answer. If you enjoyed watching this video, please consider leaving a like and subscribing. Thanks for watching.